जी अस्सलाम वालेकुम. Okay, so I'm starting the GCSE Maths course for you, where we will cover all the topics that are involved in your paper. As you know that in GCSE we are having two paper. The first paper is basically that is known as P1, it's non-calculator, and second paper is P2, that is basically calculator based. So we will discuss all the topics in detail for P1 and for P2 as well. The first topic that I'm gonna start that's related to algebra. In algebra, as you can see my screen, there are a lot of topics related to algebra, subtopics. The first one is relating to like terms, powers and roots, rules of indices, rules of indices for the fractional powers and all these things. So we will see everything in detail. Today's topic that I chose for my lesson is related to algebra. In algebra, we will talk about indices today. Also, I have some past paper question that after the topic, we will discuss the past paper questions in detail. Okay, so let's start. What does mean by indices? Wherever you saw the word index, index means something like power. Any number that contains the power is called the indices. We can say that 2 power 5. So whenever I'm considering the example 2 power 5, here 2 is acting as a base. This will be considered as base. And whatever the number that is acting as a power synonym is basically index. So its index will be 5. We can also consider the example 10 to the power of 2. So here 10 will be considered as base and 2 will be considered as index. Then there are few rules in order to solve the indices. The first one is related to multiplication. If we are having the question a power m times by a power n, so you must have to see first of all either the bases are same. If the bases are same, this is the rule of mathematics for indices. Operation is multiplication, bases are same, powers will be gonna add up. Just like I consider the example also, x power 7 times x power 12. Because x is same, just like the bases are same, so I can add up the power. Now what happens if the bases are not same? For example, counter question that I am considering it, x power 7 plus y power 2. Now see that the bases are not same. Here the base is 7, here the base is x and here the base is y. So once the bases are not same, that expression will not be simplified more. You will keep that expression same, like x power 7 plus y power 2. That will be your final answer. You cannot simplify. You will not add up the power because the bases are not same. Make sense? Next one is related to a division. Whenever you are having the a power m and a power n means the bases are same and operation is division. So always remember in divide the powers will be subtract. In multiply they will be add, but in divide it will be subtract. Now what happens whenever we are having the contra example, if we are having 10 power 12 plus 2 power 4. Now see that instead of plus, now because I am talking about division, so I am considering like divide. So what I will do for it, 10 power 12 divided by 2 power 4. I will see that either my base is same, this base is 10, this base is 2. The bases are not same. It means that I will not take away the power. If I am writing it as 10 power 12 minus 4, that will be completely wrong because the bases are not same. So in order to do that, my bases should be same. So what should be the answer for that? For that, you will keep the powers like 10 power 12 divided by 2 power 4. You will find your answer on the calculator of 10 power 12. You will find the answer of 2 power 4. Whatever the answer you are getting, that will be your final answer. Make sense? Next one is related, the same thing just like I explained you, like the things that you cannot do it. Consider the example. We are having the example 2 power 3 times 2 power 5 because the bases are same, 2 and 2, so that's why I add up the power. 3 plus 5, that will become 2 power 8. 4 power 5 divided by 4 power 2 because both the bases are same, so you can simply take away the powers, that will be 5 minus 2 and it will be 4 power 3. If you want to make more simplification, now you have to find the answer of 2 power 8. 2 power 8 means 2 will be multiplied by 2 8 times. 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7 and 8. Multiply 2 with 2 8 times and find out the answer. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 1, 2, 3, 4, 5, 6, 7 and 8. I'm getting 256. So 256 will be my final answer for that. For 4 power 3, I will do 4 times 4 times 4. Means 4 will be multiplied by 4 3 times. 4 times 4 times 4. That will be 64. So answer for that one will be 64. Second rule that you have to talk about for indices is related to multiplication again. Like how we can write in a simplified form. If the power is applied on each of the number like a power m and a power m, I can write them as a whole like a times b whole power m. And similarly, if I am provided with a times b whole power m, I can separate out the power like a power n times by b power n. It will work vice versa. Same thing for division. A over b whole power m. Once I'm gonna simplify it, power will be implemented inside the bracket and it will be solved like a power m divided by b power m. This is the rule. The things that you cannot do, this second rule will work only for multiply and divide. If you are having the addition, like if you are provided with a plus b whole power m, and you are solving it by implementation of power inside each of the terms separately, like a power m, b power m, that will be completely wrong. Because the rule that we study here, it's only for multiply and divide. You know that there are 4 operations of mathematics. The rules for addition, subtraction is different. The rules for multiplication, division different. So if you are provided with addition or subtraction and you want to make them like that, completely wrong. That will not work like that. Make sense? It means that for addition and subtraction, you are not allowed to separate out the power inside the brackets like that we did in addition or multiplication, that we did in division and multiplication. Okay. Next thing that we have to see that we consider the counter example for it, like x power 4 square. If I'm writing it as x square plus 4 square, that will be completely wrong because this is addition. It cannot be written like that. But if I'm provided with a question, x times 4 and then there is a whole square, what I can do? Now see that there is multiplication between them. It means that I can move that power inside the bracket on each of the terms separately, like x square times by 4 square. I implement the square inside the bracket on each of the terms separately. So that can be written as x square times by 16 because 4 square is 16. As a whole, I can simplify my answer as 16x. That will be my answer. Okay. Now what I will do if I am provided with x plus 4 whole square? Like by considering the general formula a plus b whole square. A plus b whole square general formula is a square plus 2ab plus b square. You have to memorize this formula in your head. If you are provided with a minus b whole square, then its formula will be opened as a minus 2ab plus b square. We can consider one example over here. For example, I am provided with x plus 2 whole square and other term is x minus 2 whole square. And third counter example, I can see that x divided by 2 whole square. Okay, now I want to solve it. I can see that here because of divide, x divided by 2. This expression I can write it as x over 2 whole square. And the rule for divide was what? The rule for divide was that we can implement the power inside each of the terms separately. For divide, it's possible. So once I want to do, it's going to be x square divided by 2 square. That's going to be x square over 4. Whenever I having x minus 2 whole square. Now see that between the two terms, the operation is subtraction. I cannot implement the power on each of the terms separately. It will be wrong, right? So it means that I have to think something else. I have to use some formula for it in order to find the answer. The formula that we will use is a minus b whole square. That we learn here. It was a square minus 2ab plus b square. A square minus 2ab plus b square. That formula we will use. Okay. So this term is acting as a. This term is acting as b. Once I open by using that formula, it's gonna be x square minus 2 times of x times of 2 plus b square means minus 2 whole square. Make sense? Okay, now putting back the values into the simplified form, x square minus 2 times 2 is 4, so it's gonna be 4x plus negative 2 whole square. Negative square is always positive, so 2 square will be 4. Negative times negative is positive, that's why I wrote positive. And 2 square is 4, so it's gonna be x square minus 4x plus 4. Here, this is because of plus. This is x plus 2 whole square. We will consider that formula, that is x a square plus 2ab plus b square. So x square, because my a is x and this is my b, so it's gonna be x square plus 2 times of x times of 2 plus b square means 2 square. So it's gonna be x square plus 4x plus 4. That will be my answer. Now observe the difference. The numbers are same. It was 2, it is 2. But it's negative, so that's why it will be opened with a negative formula. But this is positive, so it should be opened with a positive formula. So that's all about it. Okay, the third rule is saying that if you are having the power, one of the power is inside the number like a power m, and then you are having the whole power n. So it means that you should multiply n inside it. So it's gonna be a power m times n. We can consider the example like how it's worked. We can see that if we are having a power 2 and then there is a whole power that is 3. So we know that the power should be multiplied inside the power. So it's gonna be a power 2 times 3 is 6. So that's why its answer will be a power 6. Okay. Next one, if you are working with a negative power, students always remember you cannot find the answer for the negative power. You must need to make the power as positive. If you are having the number 2 power